Hey everybody, we're giving this whole online lab thing a shot here. So you'll notice that on the website we have this assignment. It still is listed as a draft for me, but we've got the virtual greenhouse lab. Right now, there's only, from my perspective, there's only the document, but here's where you found the video. If we're doing virtual stuff and there's video to go along with it, always check with the virtual assignment, like as you found with this video. What we're working on today is the greenhouse gas lab. Which looks like this bad boy. It is using a Colorado FET simulator. And you are welcome to pull this up yourself, but I will be displaying what you need to see through this video. So my personal recommendation is, rather than, tinkering with the Flash player, the whatever format this might be taking, just follow along with this video and you'll be able to see what you need to see. So we're going to start here just by determining what the greenhouse effect is. A greenhouse gas is, by definition, a gas that traps and redirects infrared wavelengths of light. So we're going to be looking at some of the most prominent gases in the Earth's atmosphere: CH4, which is methane; CO2, carbon dioxide; H2O, water vapor; and then molecular nitrogen and oxygen, just to see if they serve as greenhouse gases. You'll remember from the atmospheric composition and formation worksheet that you did last week, most of these here, besides nitrogen, really aren't that, and oxygen really aren't that prevalent in our atmosphere. So we'll just have to see what kinds of effects they can have in their current states. So what's going to happen is I'm going to be displaying what's known as a photon emitter. And this photon emitter, I can change a couple things. I can change the speed at which photons are being emitted by sliding this gauge, and I can switch if they are infrared photons versus visible photons. Right now, we have a methane molecule sitting here in the middle of our chamber, but I can switch that to things like carbon dioxide, water, nitrogen, and oxygen. You'll notice on the worksheet, the first one we're being asked to evaluate is methane, CH4. What I'm going to do is I'm going to count to 50. We're going to watch 50 infrared photons be emitted by this photon gun, I guess. And you need to count how many are absorbed. So, for example, I'm just going to let some shoot out here, and I'm going to show you kind of what you'll be doing here. I'm going to start shooting some photons. No absorption, none. There's one. 1, 2, 3, 4. So while I'm keeping track of 50, I'm going to let 50 go through there. While I'm counting up to 50, and I'll pause after 50, you're counting how many are absorbed. So just make sure that you're following along and counting how many are absorbed. If it goes through, ignore it. We're going to figure out how many out of 50 are absorbed. So at this point, go ahead and make sure that you have have your data table set up and ready to go. And we're going to start counting our way to 50, starting with methane. Here we go. Again, you are counting how many are absorbed. That is how many interact with the molecule. And that was our last one. not this one that's passing through, but the one before. That was our last one. So how many did you get out of 50? Take that number, and in your table, you're going to put that number, that's the wrong one. You're going to go however many out of 50. All right. That being said, we'll move on to CO2, count to 50, and then we'll just progress through the rest of these gases. Here we go. Let me get those out of there. We'll reset. Give it a moment. All right. Counting how many are absorbed by carbon dioxide in 3, 2, 1, go. Last one. All right, that was our 50 for CO2. Record your answer out of 50. And we are moving on to H2O. I'll get the gun reset. And here we go, water vapor. 3, 2, 1, go. Coming up on the last one. There it is. Last one was just absorbed. That was water vapor. Go ahead and write your number out of 50. I'll get us reset for nitrogen. And we're going to go ahead and go to molecular nitrogen, N2, in 3, 2, 1, go. Coming up on the last one, 50. So that one wasn't especially impressive. Let's go ahead and write our number out of 50 for nitrogen. And I guess this can act as a moment to make sure you're doing it right. What you should be typing for nitrogen is 0 out of 50. We'll go ahead and reset, and we'll get oxygen set up. Molecular oxygen, O2. Starting O2 in 3, 2, 1. Bet you can't guess what's going to happen. Coming up on the last one, 49, 50. Nerfing. Nothing happened with O2 either. So we're going to hop back over to our table, and we will see, put all of these out of 50. You should have this already. Of course, I wasn't able to follow along, so you're going to have to use the data from the video. But it should look something like 0 out of 50 for at least these last two. The next thing I'm going to ask you to do is to calculate a percentage. At this point in our academic careers, hopefully we know how to do that already. But if you want to calculate a percentage, what you do is you go, you do the division. So blank out of 50, 0, divide by 50, and you'll get a number. And then you multiply it by 100 times 100. And that'll give you a percent. So in this case, 0 times 50 is 0 times 100 is 0%. I'd like for you guys to make sure, you don't have to type out your equation, but what I would like for you to do is to make sure that you bold this in. I want you to make this especially obvious. The percentage that we're seeing here, of course, if we used a larger data set, we would obviously get a better number. But what this percentage represents is the percent likelihood that an infrared molecule or infrared photon has to interact with that molecule. Take a second to process that. This percentage represents the percent likelihood that an infrared photon will interact with that atmospheric molecule. So in this case, nitrogen, it's like 0%. Let's say that we got like, trying to think of numbers here. Let's say we got 38 methanes out of 50. In that case, it would be like it has a 76% chance of interacting with methane. But do your math and pause right now. Calculate those percentages. Pause. And now that we're back, you should have all of your percentages bolded for the percent likelihood of an infrared photon interacting with these different molecules. You've got two questions right here that I'm going to encourage you to answer regarding the most potent greenhouse gases and the least potent. Pause now to answer questions 1 and 2. And we will move on to number 3. Number 3 says, change the photon source so it emits visible photons. How do the visible photons interact with each of the atmospheric gases? This isn't asking us to count. It's just saying, if we're talking about visible photons, what happens instead? Or what happens, maybe it's the same. Let's check it out. I'm going to click my button here. It changes the color of my flashlight. And you'll notice that they represent it as a flashlight because infrared photons are longer wavelengths than light. When we say visible photons are, it's just the light that we're used to. It's reds and blues and yellows and greens and so on. So let's go ahead and just observe what happens. And I'm going to cycle through the gases, and I want you to just make a note. I'm going to put this at full blast because we just want to see, what's the photon doing? We're not counting. We're just seeing, does the photon interact or does it not? Here we go. Starting with methane. Nothing seems to be happening with methane. Let's try CO2. Water vapor. Nitrogen. And oxygen. Take your observations and apply them to number 3. How do the visible photons interact with each of the atmospheric gases? Pause and answer that question. Moving forward, we're going to go down to the next page, which asks us to switch our simulation over to the greenhouse effect. All right, so here we go. Make sure you're familiar with your questions, and I'm just going to let this play through for a moment. The The first 4 questions in this second section, they're just asking you to make observations or even do some research. So I'm just going to let it play for maybe like 30 seconds for you to observe what happens. Notice what's happening with our different types of photons. We've got sunlight photons, the visible photons, and then we've got infrared photons represented as red. On the right here, you'll also notice that we've got different amounts of greenhouse gases, like the CO2 is right now the atmosphere is set for today, so our modern atmosphere composition. We've got CO2, 388 ppm. What that stands for is part per million. So there are 388 CO2 molecules per million atmospheric molecules. So there's 388 per every million, 388 parts per million. So I'm just going to let this play, and we're going to just kind of observe what happens. Keep in mind that you can watch what's happening as the photons come in. You can see what's happening with the thermometer over here, and I'm just going to let this play out. One of the questions will ask me to adjust the slider at the bottom, so after some time I will do that as well. Here we go. I'm going to adjust the slider. And that hopefully is enough for you to see to answer the first several questions. One thing I will encourage you to do is to maybe rewind and do this if you haven't already. Watch any one particular photon and just follow it through the sky. Think about what's happening to that photon, and then, as some of your questions ask, more importantly, think about why that photon expresses that behavior. For our next portion, we're looking at questions 5 through 7. If you're not yet ready for these, make sure that you pause. Questions 5 and 6 specifically are asking us to change the greenhouse gas concentrations as it pertains, like there's a slider there, but we'll just use the slider first to answer number 5, and then we're going to see what happens when we, just change the concentration based on history, our old atmospheric evidence. So switching over here, let's go ahead and reset. And then I'm going to go ahead and I'm going to start it up. And we'll start with no greenhouse gases. And we'll watch what happens. As you watch, just for the sake of the questions, remember that it's not just about writing down what happens, but think about why it happens. What's different? And why might this be the case? Further, you can see on the left side a thermometer. This will be helpful for some of your questions. That's with no greenhouse gases. Now let me go about halfway up our slider here. What behaviors change? Make some general observations about what you see with all the photons. Does the behavior of any one individual photon seem to change? What observations can you make about the collective of photons? Them as a mass rather than, just an individual. Now let's go to lots. We've maxed out the greenhouse gas concentration. take in all aspects of what we're observing. And there we go. Take a second to answer the questions that you can, given that information. I believe that was number 5. Go ahead and pause and answer that. For number 6, it's asking, what about these different concentrations throughout Earth's history? So I'm going to go ahead and let it play out with today's atmosphere. You can tell that today sits right here on the slider where it's not at lots, but we're a little more than halfway. Oh, I should probably reset this, huh? I'll just let this run for, I don't know, like 30 seconds. We've already seen this happen once, but maybe consider, look at what's happening with our thermometer. You can see the concentrations and the composition, the makeup of the atmosphere over here on the right, the greenhouse gas composition. We'll go ahead and reset and do 1750, which is this blue line. And we'll reset and switch to the Ice Age. Remember to keep in mind that you can see the greenhouse gas concentrations over here on the right. And with that, we're about ready to move on to the next section. At this point, go ahead and pause and make sure that you've got questions 5, 6, and 7 answered. In our final section here, we have the last section, which is the glass layers. So we're going to familiarize ourselves with that setup over here. We're going to switch to glass layers. And what we can do here is we can't change the greenhouse gases, but we can do is we can add glass panes. So you'll notice that these glass panes have been added. So we're just gonna play around with it. We'll start and I'll add one glass pane, and we'll watch what's happening with our photons, and we'll watch our thermometer. Then I'll add a second one. We'll watch our photons and play with the thermometer. And then these questions, they're all reflections on that. So this one's pretty straightforward. Basically just got to let it run and let you guys watch. So here we go. We'll start with no glass panes. This is also assuming no atmosphere. Just keep in mind. I'll add a glass pane. Very obviously, you'll notice that the temperature has skyrocketed here. But think about why. What is making that temperature gauge go up? This temperature gauge sitting at the surface. Glass pane number 2. And glass pane number 3. Okay, now that we've run all the way through the simulation, you are ready to complete your lab. So go ahead and, just check back through those questions. Think about the hows and the whys, and enjoy that last question. That's a real thinker, but it brings the applications back in. So that being said, we're good to go, and I'll see you guys soon.